For coming. Nayan, it's great to have you with us. I worked with Nayan. We worked on a big project for a number of years, and I was thinking back to some of that, and I remember we had been working on this thing for about 4 years, and we are getting ready to launch it. And I was in Parkersburg, West Virginia, with several people. Nayan was in D.C. with several people, and Nayan had the great idea that once we actually kicked off this big process that was going to move us to the new system, he was going to play the rock song "The Final Countdown." And so we kicked it off, and Nayan started the song, and it's playing over our video conference stuff, and then like something wasn't right, and we need to tweak something, so Nayan stops it, and 5 minutes later, it's like, okay, we think we're ready. So Nayan kicks off the song again. I think it took us 3 or 4 times, and I was just very impressed with the amount of determination Nayan had that we were going to hear the final countdown when we actually kicked this thing off after like 4 years of work on it. But
Dedication.
anyway. So Nayan's joining us today to talk about testing in production. I'm looking forward to this. There is a Slido up for Q&A. Nayan can't see it for some reason. So if you have questions, put them in there, vote them up or down, and then we'll have some time to take a look at those. I'll read it to him when we get to kind of a natural breaking point or when we get to the end. So thank you everyone for coming. Nayan, great to have you here. I'll turn it over to you.
All right. Well, thank you, everybody. Great to see you, and I have fond memories working with Mark as well. That project probably would have been a good one for us to do more testing production, and it probably would have gotten us to our goal sooner. But it was good in any case. The last time I gave this presentation was in front of a live or a in-person audience, and so it was easy for me to get feedback from the audience and so on. So this is going to be a little different this time, and so we'll just do the best we can here. I won't ask too many questions because a lot of times I like to say, hey, how many people have done such and such, and that will be very difficult in this context here. So normally what I would ask here is how many people test in production, and usually there's not too many, or people tend to say inadvertently. So all right, so we'll kick it off here. So what are we talking about? We are talking about testing in production, and you've probably seen a meme like this or something to this effect. I don't always test my code, but when I do, it's in production. And when you see this, usually what people are kind of joking about is that they shouldn't be testing in production, but they are, and that's it's not the greatest way to do things, but they're just kind of flying by the seat of their pants. So that is definitely not what we're talking about. So what kind of tests are we talking about? We're talking about you might have seen this testing quadrants diagram before. It was put together by Brian Merrick and then kind of popularized by Janet Gregory and Lisa Crispin in their Agile testing book. And it kind of just describes a lot of different kinds of tests and where they kind of fall and who's responsible for them and those types of things. For the sake of production testing, we're talking about some specific things. So we're not talking about functional tests. We're not talking about example tests, story tests, unit tests, component tests. Those are all automated tests that should be running as part of your build or whatever, and before things even get into production. So these are things that are happening automatically. But there are tests that we can't or don't want to automate. Maybe there's some tests to third-party systems that we have to test against their production environments or things like that. There's tests that require some scale, so we might want to do some sort of load testing where our non-production environments maybe don't have the same capacity that our production environments have. There might be some smoke tests, so we want to just make sure that the application is actually up and running. How do we validate that? And again, some of these can be automated or not, depending on how you're setting it up. Okay, so there's like I said, there's going to be a varying degree of different types of tests that we're going to be talking about in production. And but before I get to that, just a little bit about traditional testing environments. And I imagine that folks here, a lot of people are probably in places that have you know, one or more pre-production environments. So you might have your development environment, and then you have you know, QA environment, maybe a staging environment, maybe a pre-prod environment, maybe a load testing environment, etc. And a lot of times, at least, you know, what I've seen is that you get to situations where, well, it works in QA, you know, that's like the old, you know, it works on my machine kind of thing, right? So that it works on my machine was largely solved by people implementing things like continuous integration, where if it didn't work on the continuous integration server, then, you know, it doesn't really count. So get it working on the continuous integration server, and then we can make sure it's working on everyone's machines. Just saying it works on your machine isn't enough. And, you know, we're often in cases, or I've seen a lot of cases, at least, where things get deployed out into a production environment, and all of a sudden you say, oh, it's not working in production, but it worked in QA. So now what? So essentially you kind of are seeing production, you're testing in production. Is there a problem with the slides? I just saw somebody comment about that. Okay.
I think it's all good now.
Good. Okay.
It's good now. Okay.
Yeah.
All right. Thanks.
All right. Okay. So what are some other issues that come up in traditional testing environments? So they're very difficult to set up correctly. And, you know, people have tried to do a lot of things like, you know, IAC, infrastructure as code, things like that, in order to make environments repeatable. You know, all I can do is just, you know, have this script, whether it's like, you know, Terraform or Ansible or, you know, something like that. And it just will spin up my environment for me. That's all well and good, but they're hard to get right. And even when you do set up those environments using those scripts, there are still going to be differences between the environments. They might be, you know, our production environment has, you know, 12 nodes, and our test environment has 3 nodes or whatever. You know, there's going to be some sort of differences. You know, the environment variables are different in this environment versus the other environment. The memory settings are different, and so on. So all those things can be variable. It's difficult to achieve parity with production. Is kind of what I was talking about the scaling in particular, because, you know, it's expensive. You know, if you're running 1,000 nodes in your Amazon cluster or something like that, you don't necessarily want to have a 1,000 node test environment. And then, you know, where do you cut that off? You know, do you have that same do you have like a pre-prod environment and maybe a QA environment, maybe your QA environment? How do you decide, like, should we have 10 nodes, 20 nodes? I mean, you know, where do you make that judgment? And if you have parity, then essentially you're doubling your cost of maintaining these systems. Maybe you don't have as much network throughput or something like that, so it might be a little bit cheaper, but it's going to be expensive to keep all of that running. The old, oh, we forgot to deploy the X to the Y problem, right? So I've got, you know, this component over here. It was supposed to be deployed out, and we deployed that one, but we forgot to deploy the one that it depends on. And, you know, which version is in production, which version's in our QA environment, which version's in our, you know, development environment, et cetera. So keeping track of all that kind of stuff, it's just added overhead. Test data. This is a big one, I think, that people struggle with quite a bit. How do we ensure that our data that we're actually testing with is useful? Usually data that's in test environments, or a lot of times data that's in these big test environments, tends to be like a copy of old production data or something along those lines, because they wanted to try to replicate what was happening in production. But it's very difficult to then keep that up to date with what's currently in production, without having to do like a full reload. And then you have to get into like, well, now we have to schedule when we're reloading it and notify all the teams that are using it. And, you know, it takes, you know, 24 hours to reload the system, so nobody can do any development then. So we have to have code freezes, and all sorts of other complexities start coming in when you start running into that. And then, you know, that then speaks to the reliability of the test, because you might be now deploying something or testing something against test data that maybe just doesn't make sense. Like, that situation would never occur in the production environment, because whether, you know, when you got the copy of that data from production, there was some sort of bug that was allowing that data in. Now it's no longer allowing that data in. And so now you're testing against data that's bad. So how do you identify all of that kind of stuff? Makes it very difficult. And then, of course, we're telling our business customers or whoever is, maybe doing some user acceptance testing, maybe have a UAT environment or something. We're telling them essentially, make sure this fake system works the way you want it to, rather than saying, here's the system that is in production, and you can now look at it and see that it works correctly. And if it works correctly, then it works correctly. You don't have to say, oh, well, it should work correctly. We're gonna just trust us. We've got it all under control. Look at this fake system, make sure it works okay, and then we'll do some magic, and then all of a sudden, hopefully, the production system will work, and then test it there again. Just so double all of your testing efforts, right? All right. So why would we want to do this? So I think we've kind of touched a little bit on the whys, but I'll get a little bit more into that for a second. So we've got the three little icons there. I always give people a quiz to see if they can figure out what these icons mean, but we're not going to do that right now. All right, so the first one, shorter cycle time, right? So we've kind of touched on a few of these things. I think it's pretty straightforward. So just, under the assumption that your production testing system is working great, and it's very effective and all that kind of stuff. So just pretend that's the case for a moment. If that were the case, you can imagine that, well, I don't have to go through these extra environments. So there's a shorter cycle time from the time that I'm starting to build something to the time that I get it to the customer. And so that's generally beneficial for companies to decrease cycle time. Faster feedback loops. So we're getting actionable, real information about whether something is working or not faster. So again, we're not in the situation where, well, it worked in QA, and now we wait it a little bit, and then now we test it in production, and then maybe we find out that sometime later that it wasn't working. We'll get that information much sooner, that something wasn't working the way that we expected to. Lower infrastructure costs, we already touched on that. Eliminate an environment, obviously it's not going to cost as much. All right. So what is stopping us from testing in production? I think one of the big ones is just tradition. So that's just not how we do it. We have a QA environment. We have a PreProd environment, and so that's what we should do, because every company have those things, right? So that's a pretty strong one. Some of you may have seen this phrase here before. We're uncovering better ways of developing software by doing it and helping others to do it, right? We are not saying that we have discovered all of the ways of developing software. So, if you, keep your thoughts open, you can consider this a different way of developing software. Maybe it's better, maybe it's not, maybe it works for you, maybe it doesn't. But it's trying to experiment with new things and trying to do the helping others do it part of it right now. And this is from the Agile Manifesto. In case I'm getting a little bit of audio feedback from something, I'm not sure what exactly. All right, and then I think one of the big ones is fear. I just tried to make some scary monsters here, so it can be scary to try something like this, because our goal here is to do this responsibly, right? We're not trying to just throw caution to the wind and just be like, whoa, hey, just throw everything into production and just see what happens, and it'll hit our customers and negatively affect them and impact our bottom line and all that kind of stuff. We're definitely not interested in any of that. The reason to do this is to make things safer, easier, faster, cheaper, all that kind of good stuff. Okay. All right, so now on to the how can we do it part. So when actually implementing a testing and production strategy, how do you actually do it? All right, so the first part, I think, is that you have to understand what is test data, or what test data is in the context of your system. So you have to know, if you have a application that's running in a production environment, you have to know what test data is, because you're going to want to, even if something's running in production, you're going to want to be able to test something in production, right? So this is just an example of some code. You don't have to be a coder to appreciate this. I think there's like it's a REST endpoint, an API endpoint. And the key thing in this particular endpoint is you'll notice this line here. Oops. There we go. Sorry. This line right here, I guess I can't click on it, says run environment, and it comes in as a request header. So what this is saying is that anytime you make a request to this endpoint, tell me what environment we're actually talking about. Okay. So this code is going to have to know. You notice that it passes that run environment on to the next method that it's calling. And so this application has been built such that it understands what environment it's expecting, or how to handle different environments. So if I were calling this endpoint, and I said and passed that run environment as prod, for example, it would do the production stuff. If I passed in test, maybe it goes and returns a little bit of fake data. Maybe it calls some, rather than actually calling the payment processing endpoint, it just maybe writes out to a log file that says, if this was prod, it would have made this particular call to that endpoint. With this data and so on. And so you can then go into the log and inspect it and say, okay, well, it looks like, the parameters were all set properly and they would have gone this way. Obviously, we didn't want to make that payment to, American Express or whatever, but we'll be able to just validate that it would have done the right thing. Okay. Or if if your third party has like a test environment, maybe you can route the requests there and so on. So there's lots of different things you can do. But the key point is that the system that you're writing has to understand how to that it is a test, or when it's in like a kind of a test mode and when it's not. Okay. And likewise, it can then send this information. So if I'm talking to a test environment or to a system that knows how to handle test environments, I can pass along maybe a header or a query parameter or something like that as well. You'll actually see this kind of thing a lot in public APIs. A lot of times, when they don't have, you might have like, something.com that you can, hit, and they might have like a dev.something.com that you can hit. They might also have just like the regular URL with a query parameter on the end that they're passing in and say, test transaction equals true or something like that. There's lots of different ways you can do this. And you can even route them through those top level domains too. So you can say things like, if my request is coming into the dev dot whatever, then set this particular header parameter or whatever. So there's lots of, there's like a million different ways you can do this. But the key point is the system you're writing should understand how to understand what environment it's being requested to do something for. Okay. All right. And then I think the second key part that you need to be able to do is controlling what customers see. And you've probably commonly heard of this in the being called like feature flags or feature toggles and things like that. So if we're constantly pushing things out into a production environment, we don't obviously want our customers necessarily to be seeing all of these things all the time. And so the way that we do that is that we use something called feature flags and feature toggles. And essentially what that is that they're just conditionally enabling or disabling features for particular sets of users or sets of users. And again, there's a million different ways to do this. There's the libraries that let you do this. There's third-party services that you can integrate with, like things like Optimizely and whatnot, that let you do this kind of thing. In this particular application, it was just literally, this is just a, it's a Boolean test on a variable. That's all it is. There's nothing more complicated than that. There's no API or anything that we're integrating with here. And this enables us to release stuff to the customer or release stuff into the production environment. And then individual users or sets of users can then enable or disable a feature flag, see how it works for them. And if it looks good, in our case, the project I'm working on right now, our business customer and or other people who are interested within the company will test it out in the production environment, see if it looks good. If it looks good, then we remove the feature flag and now it becomes a production feature. These are intended to be short-lived things. There's, your code should not be littered with feature flags, and they should also exist really only at the endpoint. So again, you like for a single, if you're enabling the secret sauce here, you wouldn't expect throughout the code to see this this if statement. You would see it at the entry point to this function. So if you have like a page where it's showing up on, or if it's an API endpoint or something, you might see it there, but you wouldn't expect to see it like down in the depths of the database layer or something like that. The feature flags are only relevant really at the entry points. Okay. All right. So we have to play nicely. We have to live next to each other. So there's oftentimes when we're building systems like this, you say, well, it's all well and good. I've made a super compelling argument, and obviously everyone's going to go out and want to do production testing right away. But the rest of my company doesn't do that. So what do, right? So the rest of my company, we have a dev environment, a QA environment, a prod environment. And in those environments, they have some legacy development, legacy QA, and legacy production systems. So what we can do if we're trying to adopt this type of approach, essentially what we can do is have a little layer, because we don't want to have to, we don't want these legacy environments to have to like learn a totally new way of doing things. Not that it's super hard to pass a header variable, but sometimes people have a hard time with it. So in any case, an approach, and again, there's again a million different ways to do this, but this is a way that works. You can have this new system that you're developing. Maybe you deploy some sort of like almost like a little proxy layer within the old environments. So within the dev environment, the QA environment, the prod environment, and essentially all this guy does is it will just essentially proxy that to your new system, and it will put the appropriate header variable or query parameter or whatever it is on the request, and then forward it on essentially to the new thing. So yeah, you might say, oh, well, that's an extra hop that you're adding. Yeah, but it's depending on what the nature of your business is, it may or may not be that important. If this was a high frequency trading system, maybe not the best approach. But for most business applications, this is probably perfectly fine. And this can be very fast. My guess is that if you're having performance problems, this is probably not where the performance problems are. Yeah. And then maybe the other new things that the other new systems that you're building, this new B and the new C component, you just take that parameter that came in and you just pass it along to the next systems as you're building them, and they know how to handle those already. So you just do what you need to do. And then those might be calling back into some legacy systems. And so at that point, you would use that variable that's coming in as a decision maker to figure out which one you want to point to. So, I think, sometimes you might think, well, this just seems like it's a lot more complicated than just keeping everything in dev or keeping everything in QA, keeping everything in prod. Maybe just at these tiny little endpoints, that's true. But the reality is when you're maintaining systems and deploying the systems, a lot of the time that gets wasted is in managing and maintaining these other environments. So if you can eliminate that cost, the little bit of extra cost that it takes to do this kind of thing, essentially, which is like an if statement, not a big deal, is pretty minimal and will save you a lot of time and money. Okay, there's our production system. All right, so performance testing. So some people get really panicky when we talk about performance testing in a production environment. And I think the reality is that a lot of people approach performance testing maybe not in the most useful way. You can do performance testing, obviously, to do like stress testing, where you're trying to see at what point your system fails. Maybe that's not the best thing to be doing for your production environment. And also, it seems like that's not necessarily the most useful thing to do. Really, what you want to do, in my opinion, most of the time, and again, there's always exceptions, but most of the time what you're trying to do is see if your system can handle whatever your expected capacity is, maybe with some growth factor or something like that. You're not really trying to see if you can bring your system down. And so the way that I usually suggest doing this is you have your production system, you've got your environment variables, so you can, or those parameters, so you can tell it that these are test transactions coming in, and you start scaling it up slowly, just very slowly. So you have some baseline that you're starting to use, your system can handle that. You add, 10 users, 20 users, 30 users. You keep scaling up slowly. You monitor it. This requires that you have good monitoring on your systems. If you're just guessing and your way you monitor is to like load your website and just count the seconds to see how long it takes to load, that's not good monitoring. So you need to have some real deliberate monitoring built into your system, so you can monitor the response times, monitor the CPU usage, memory usage, et cetera, and see if your system is handling it. If it looks like customers might start being impacted, if your response times are starting to take a hit, or I guess take a hit this way, scale it back, figure out where the bottleneck is, repeat. Okay. This approach, I think, is way more beneficial than trying to do this thing in this type of a test in a performance testing environment, which, as we've already talked about, is really difficult to set up at the scale that your production system is. And this happens, as company gets bigger and more profitable, and you're building more servers and things like that, it becomes harder and harder to have a real performance, a production-like performance testing environment. So doing it in production really is, again, in my opinion, really the only way that you can do it effectively. Okay. All right. So I only have a few more slides. This is, and then we'll open it up for questions. But I think we want to. There's a lot of. So I mean, in concept, this is actually a very simple idea, right? In practice, of course, things are a little bit harder, and there are certain practices, development practices, that make this type of production testing easier. So while they're not directly related to this is required in order to do production testing, they will make your life a lot easier. The first, obviously, is robust automated testing. Test everything that you can. That is, really, really important. Anything that's, you can automate it. The more you can have, the more that you can test that way before it even gets into your production environment, the better. So you can test all these things in your continuous deployment pipeline. Okay. Continuous deployment. So good segue, I guess. This seems to be a trend in the industry right now. Like, everybody has a CI/CD pipeline. And I feel like a lot of people don't know what a CI/CD pipeline means. So this is meant to be a continuous deployment pipeline. If you say CI/CD, that's what you're saying. You're saying I have a continuous deployment pipeline. What is a continuous deployment pipeline? That means you commit your code. There are no manual steps. So nobody's clicking any approval buttons or anything like that. There's no gates. There's no manual testing. It goes into production. That is continuous deployment. So commit to production with no manual steps. Just calling it a CI/CD pipeline doesn't mean it is a CI/CD pipeline. So that'd be fine. And there's nothing wrong with not having a continuous deployment pipeline, but it's just misleading, I think, when people keep saying CI/CD. But having continuous deployment makes production testing easier. So this is, an example from, GitHub Actions. You can see here, it's probably, this is actually kind of an old slide, but in any case, you can see there's deployments that are, they take about 5 minutes to deploy. They're happening every commit, which is, looks like there's a few within a day. So it's like, 5 or 6 commits in a day. The team I'm working with now, it's not unusual for us to have like 20 to 30 deployments a day, occasionally. So yeah, so just getting things out there rapidly makes it much easier to figure out when you're testing, or what you're testing. If it has to be a big event in order to get something tested, then it probably means that you're batching a lot of changes together, which makes it harder to validate and make sure that things are working okay. If you're getting things right out into production and you can tell your customer, hey, go and take a look, and just verify, we moved this button over, 5 pixels this way. Does that look good to you? Great. And then you can move on with your life. You don't have to say, you don't have to think about that particular feature anymore. You can just move on to the next feature. Yeah, so this continuous deployment is a really good one. Trunk-based development. I don't know how many folks have a branching process that looks something like this. You're trying to get your code out to production, and you've got your main or master branch, and then you've got your different testing branches, release branches, hotfix branches, and there's a thing that was popular for a little while called Git flow, which is kind of like this. It can have its place, but this is pretty complicated, and it's hard to keep track of what goes where and when you should be doing things. This, again, is not continuous integration, right? This is integration whenever we choose to merge back to master, generally. Continuous integration really means anytime you're making a change, it gets integrated back into the code with everybody else's, so you can validate that it works. This kind of a scheme generally is not that compatible with continuous integration. So one of the things that I think is very helpful is trunk-based development. In fact, it's so simple that you've got different people committing there. Even a baby can do it. That's how easy it is. So all it is just committing things directly onto master. And these are there's a lot of good practices that come out of this. So when we start thinking about trunk-based development, we start thinking about our changes as we're committing them, that, hey, when I'm committing this, I should probably make a small change so I don't impact a whole bunch of people. So you start making smaller commits. You also, when you're thinking about like continuous deployment, you're thinking about, this change is going right into production. Let me just think about it for a second. If you have this period of time where, you can make a commit and then it goes and sits in your QA environment for 2 weeks, maybe you just don't care as much, or, you might care, but just subliminally or subconsciously, it doesn't have a sense of, I really better make sure that what I'm doing makes sense. And I also should make sure that I'm committing things in a way that is incremental, that can be easily rolled back, like all those types of things. And it's not that you have to go into like a detailed design session or something like that to understand how to do this. These are just like small little things that you think about as you're writing your code. So it just makes you a little more careful, and I think it generally makes the quality of your code go up. Okay. And then, of course, the final thing that is kind of just at the heart of any sort of agile thinking is continuously adapt practices and processes. What works for one person may not work for another. I was recently, a few projects ago, I was doing this thing where we were struggling. We had like all these applications locally that we were trying to test, and in order to test them, we said, oh, what would be really helpful is if we built like fake versions of all of these services that we're having, so that we don't have to stand up our whole environment together. We can just stand up the one, and then whatever corresponding fake services it has, essentially like little mocks or whatever. And then we can just run these applications independently. Worked really great for us. We kind of built that in after we had built these services, and it worked out really well. I went on to another project, and we were starting to build up a similar type of thing. And before we got started, I was like, what we should do is build these fake services, because that worked out really great on this other project, and we blah blah blah. 6 months, 8 months into the project, nobody had ever used a single one of those fake services, and we had spent all this time putting them together. And so it was just like preemptive optimization. So even it's not even what works for one. It's like it worked for me once, and then it didn't work for me the next time. So you just have to be sensitive to what actually your environment is like, and just keep doing things that work, and take out things that don't, and don't be afraid to stop things. So and then, kind of like I mentioned, even if you don't end up actually testing in production, just thinking about whatever is preventing you from actually doing it, I think will generally make your systems better and the way you approach code better. So, things like, oh, well, we can't test in production because we need to have, a security scan before it gets into production. Our security department needs to look at it. Well, that might make you think about, oh, well, is there a way that we can automate our security scanning? Is there a way that we can, incorporate the people who are doing the security testing earlier into our development process, so maybe they don't become a gate. There's all sorts of things like that if you just kind of think about what's preventing you from doing something, you can strip those things out and make your whole process better. So that's basically all I have. It's I think it's been very helpful for me and the products and projects that I've been working with to be able to do these types of production testing things. And so hopefully it gives you some food for thought.
It's inspired a lot of questions, so that's great, right? So, so let's see. John asked, "Have you found a lot of organizational resistance to putting anything into production that isn't considered production code from like security?"
Yes. Yep. Sure have. And I think that I guess a couple things to say about that. And typically when it comes to anything security related, I find that there's a lot of mythology within organizations. So people will say things, it goes for security and also like audits and things like that. People will say often, oh, we can't do that because the security guys say we can't, or we can't do that because the auditors can't, say this. And in my experience, the best thing to do is go and talk to the security people, go talk to the auditors, and find out what they actually think about this. Because a lot of times these are just stories that are built up over time, and nobody's actually talked to the security guys. No one's actually talked to the audit folks. And so just go talk to them. And chances are, they want to help you build better software. You want their help to build better software. If you don't want their help, there's probably something else going on culturally or something that is beyond the scope of this talk. But yeah, I think those barriers are overcomable, but you just got to find the right people to talk to.
I remember some situations I've seen where once you started and actually asking, well, what's the actual policy we need to adhere to, it not only did not prevent you from doing it, but it told you exactly how to do it safely. And it's like, okay, well, it's a good thing we didn't just ignore asking the questions because we didn't think we could do it.
Yeah.
We'll ask, with modern cloud-based architectures with IAC, is this still the way to go? We can easily spin up and tear down environments.
Yeah, and I mean, it is not the way to go, right? It's a way to go. At the beginning of the talk, I was talking about, one of the reasons to adopt this kind of thing is cost. So yes, IAC is great, and it's easy to spin up a whole Kubernetes cluster or whatever. But are you really doing that to test your stuff? Maybe you are. And also it's expensive. Now, if I have to spin up a 30 node cluster to test my thing, is every developer in the company doing that? Spinning up 30 node clusters at the drop of a hat? That's probably not what you want. So it's like I said, this is definitely not the way to go, but I think it makes a lot of sense in a lot of cases. And also the thing about IAC, again, it's great, but just because it's infrastructure as code doesn't mean that it's going to be consistent between environments. And it could be even things like, we tested it in Amazon's East environment, but in the West environment it fails. So how are you going to find that out? Well, the only way you're really going to find out about it is when you actually deploy it to production and find out it doesn't work in the West environment, right?
Eventually, everyone is testing their code in production,
Yes.
right? You eventually deploy it to production and see if it works. Right?
Yeah.
Richard was asking, this presumes a modern, loosely coupled architecture, no? This seems difficult or impossible with legacy systems or applications. Or are there strategies for such dinosaurs?
I think there are strategies for legacy applications. I think certainly it's harder, and I think certainly it's cultural, a very cultural thing. I think the first thing that you need to do for most legacy systems, which tends to be the biggest barrier to overcome, is actually just improving deployment frequency. Because if you're in a situation where we're only deploying once a month or something like that, then if you make a change, if you mess something, or not necessarily mess something up, but if you deploy something into production that's not how you expected it to be, and it takes another month then to get the fix in there, well, I mean, that's very slow. So having an earlier environment where you can more rapidly make those changes is good. But then what I would question, if you start thinking about this, right, what is preventing me from deploying this legacy application to production? Oh, well, I'm afraid that we're going to break stuff. Okay, so if you're afraid you're going to break stuff, why don't we try this? Whenever you do your next deployment, the next day, do the exact same deployment and see if that works. If that breaks, you better fix that problem and do a zero change deployment until you can get it right. And once you can get that right, introduce a small change and do another deployment. And I think the big issue with these big deployments, the legacy deployments, is that people are so used to jamming so many features into a single release that when there are problems, it's really, really difficult to figure out what the problem was or how the different things interacted with each other. If you get to small, fast releases, even if they're for big systems, you can really quickly identify and roll back changes if you need to. So I think that's one of the big things that you should kind of look to try to improve in those legacy type systems.
I love that idea of just saying, can you deploy it when you don't think it's going to change? Because if that's breaking, you've got some serious problems that have nothing to do with the actual code itself, right? Or maybe it has to do with code. So that's great. Okay, so the distinguished Jeff Braxton asks,
Hey, Jeff.
more clarity or discussion on faster feedback loop. Is it due to the types of observations seen in production or observations in lower environments versus production?
Yes. So I think that so a lot of times I think in lower environments, people will see things that are not real things. So they might see an issue occurring in a lower environment that never occurs in production, and everybody knows to ignore the thing in lower environment. So we see, oh yeah, this thing always fails there. Just ignore that. And every time somebody new joins a project, you have to tell them to remind them to ignore that thing. Meanwhile, they've already spent 5 hours trying to debug that problem that they didn't really need to. So there's faster feedback from that. And then faster real feedback from production. So you're getting faster feedback from your customer or from your, again, usually things are behind feature flags. So you can ask your business customers or whoever they are to validate that, hey, is this the thing, how you actually want to see it in the production environment? Because sometimes there are features that are in lower environments that are also maybe just like turned off or something or configured slightly differently. So they might say, well, it looks okay, except it should be slightly different in this particular way. And you're like, oh, don't worry, when it's in production, it'll be like that. And they're like, okay. And then it gets to production, and they're like, wait a minute, I thought you said it was going to, it just short circuits all of that kind of nonsense, which is really just wasted time. So you end up with faster feedback that way, and probably in a bunch of other ways too that I can't think of right now.
Well, it seems like it would also be putting a lot of pressure to do smaller things all the way to production, so you take on less risk. So you've kind of got it faster feedback, but it's driving it from both sides. Like we can see the information faster, and we're also trying to do smaller things that are easier to check.
Yep, for sure.
Stephen Kinway asks, how do you manage merge conflicts with the trunk-based development? We tried to do it previously with the but the merge conflict resolution was next to impossible.
I think that just like everything, it's a skill. I think that you have to just kind of work on. The prime thing I think is small commits. So if you're doing small commits and frequent commits, your chance of merge conflicts are low. And when you do have them, the changes are so small that it's easy to resolve. Another thing is if you have like a lot of people interacting with the exact same code base, there might just be something structurally wrong. Like, it's fine to be working in the same code base, but then, if everybody's working on the same files, that seems a little strange. So there might be something going on, just like in the way that you're divvying up features, or maybe the way that the team is working. You might consider doing things like doing more mobbing or pairing, so that more people are kind of, using their brains together rather than typing at the same time. Because, as we all know, typing is not the bottleneck, it's the thinking about the problems. And so as you can, if you can work together to get your ideas out and into the code together as a team rather than individually, like that's really like, talk about continuous integration, right? That's like really continuous integration at the thought level. So I think, those are probably some good ones. Make sure you're using good tools. Like if you're not at this point, I think if you're not using something like Git, get there. Like if you're still using Subversion or something like that, it's time to move on. Conflict resolution and so on is a lot easier and simpler with those kinds of tools. So, but primarily small commits and frequent commits, I think, is the big one.
Okay, and it sounds like part of what you're saying is if you're running into conflicts like that, it's probably a symptom of something else you need to change in either the way you're working or your tool set. Okay. Okay, well, that gets through the questions in the Q&A section there. Does anyone else have any other questions or heckling you want to do for Nayan? That's
Heckling
always
is
an
fine.
option too.
That's one advantage of the remote meeting is that it's harder to heckle, I think. I don't know if the audio's off, but
Okay, well, I will see if there's any other questions. Anything shows up there. I'm going to actually stop the streaming just in case anybody wants to stop